On behalf of RBCS, RBCS Australia, RBCS New Zealand, and Software TestWorks, we welcome everyone today to this webinar on code coverage metrics, how to use and misuse them. I am Rex Black, President of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. RBCS has offices in the United States, Australia, New Zealand, and Sri Lanka with partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with measurable return on investment. RBCS has a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. RBCS has helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to customers. I am the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1 and 2, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I hold a degree in Computer Science and Engineering from UCLA. I'm also past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. Before we start the presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, please feel free to submit them throughout the presentation via your webinar interface. There's no need to ask for presentation copies, as the presentation will be on the web at www.rbcs-us.com. If you are having problems with the audio or visual components of this webinar, please contact GoToWebinar support. If for whatever reason you cannot get to the webinar online, or if you are dealing with an unreliable connection, please download the slides from the basic library at www.rbcs-us.com. Be sure you use the telephone to connect, not voice over IP. And one more note before we start. The last time I did a webinar, just a couple weeks ago, it was snowing here in the Texas Hill Country, and now it's spring. So there's just no understanding the weather these days. Before we start, give me one moment, please. I want to check a technical issue here. Okay, thank you. I wanted to confirm that everybody could hear me because I was having some audio weirdness earlier. So today's presentation is on code coverage metrics. Lots of people are interested in unit testing these days, and one key to unit testing is achieving adequate code coverage. But what code coverage metrics exist, and how can we use them? And how do we make sense of what certain unit testing tools might tell us about coverage? So this presentation is designed to help you sort some of those details out. So code coverage metrics are basically tools that will allow you to measure the extent of white box test coverage. Now, when I say tools, I'm using that term loosely, not necessarily automated testing tools, though there are automated tools that do this. But they're techniques that will measure how much white box coverage you've achieved. So at an overview level, what are the types of white box coverage that can apply? Well, we're going to look at 4 groups in this presentation, 4 groups of code coverage metrics that you might run across or encounter either in the use of some sort of automated unit test tool or in your studies of the field of testing, and this should help you make sense of these. The first group will be what would be called sort of classic control flow coverage, which is statement, branch, condition, multi-condition, multi-condition decision, and loop coverage. And those are, you know, if you read, for example, Boris Beiser's book, Software Test Techniques, you'll run into those there. Now, the next group is McCabe's cyclomatic complexity and the basis path and basis test concepts that are put forward in that technique, and that's something that you might run into. For example, there's a paper out on the internet. I don't remember the exact URL, but if you do a Google search for structured testing McCabe, I think would be the right keywords, you'll find this. It's an extensive PDF that describes this whole concept, how it works. Now the next group is the set use pairs, which is looking at data flow. Now the previous two were looking at control flows, in other words, the sequencing of statements. In set use pairs, what you look at is data flow coverage rather than control flow coverage, and you try to figure out how data is moving around in between data structures in the application and design test to cover that. And then the last is the checklist-based test requirements technique that Brian Merrick came up with, and this considers both data and control flows, as you'll see when we get to it. So we'll look at each one of these techniques. Now, we're also going to take a look at how white box testing compares to other types of testing in terms of, for example, its defect detection capabilities and what it can and can't do for you. Now, are there tools available to help with this? Yes, there are tools, and we'll talk about that a little bit towards the end of the presentation. And we'll also talk about the kind of bugs that white box testing can miss, because it's important to understand that just because you've quote-unquote covered the code does not necessarily mean that you have no bugs left and that you can have 100% confidence in your software. So, code coverage and white box testing, what can we say about those in general? Well, one thing is that we can say that these are dynamic forms of testing when you're looking at code coverage. In other words, the object under test, the system under test, has been compiled or is being interpreted by an interpreter, if that's how it works, and it is actually executing. And so that means that the item under test is executing. We are creating test conditions by submitting inputs and other types of events, and then we are actually comparing the actual versus the expected results. Of course, that's key to any form of test execution. If you're not comparing the results, then there's really not a whole lot of point to what you're doing. Now, I've looked at this a few times with a number of clients, and one of the things that we've found, if you take your system under test and you produce what's called an instrumented version of it, where you can measure the code coverage that's being achieved, and you look at the purely requirements-based set of tests, it's not unusual to see that you're actually only covering about 20% of the code, which is pretty dismal observation, I suppose you could say. But it is the case that that is often a lot of holes in your code coverage when you use purely requirements-based type of approach. So it would be good to know what 80% of the code you're not testing, so that you can figure out, is this something I need to worry about? Is this a hole that I need to fill? And that's an important aspect, even if you're not involved in doing unit testing. If you're just a system tester or acceptance tester, and you say, hey,